explain, repeat the solution that was shown in the example. Okay, so that's the plan for today, and let me start by sharing. And share first. I'm sharing this whole thing now. Can you see this?
Yes, Pak.
So let's just review from the very first class that we had some weeks ago. Okay, so first, this is the first PPT that we discussed together, and here we discussed about the basic concept of the engineering mechanics. Basically, it's just a branch of physics, so it has to be based on the physical property of an object. So we have object influenced by a force. Okay, and then we learn about also room or area, which is the coordinate x and y axis, and this one can be in this direction like you see in the PPT, or it could be tilted. It's depend on you. Just like when you learn about engineering drawing, the x and y is you're the one who define it, right? They provide in AutoCAD, where the x and where the y, but where do you want to put your drawing is up to you in that space. Same as this. Yeah, it could be in the horizontal or vertical direction, but it could be also tilted, not exactly horizontal or vertical. As long as still the same property that between x and y is perpendicular. Okay, this one, and we learn about the very basic concept of physics, which is mass, time, and force. What is force? Yeah, applied to an object. It could be distributed in constant like an A, or a B distributed not constant, just like in a picture. Okay, or it's concentrated in one place, like this one. The W is concentrated, so you need to calculate this whole force and then exchange with this one concentrated force. Yeah, I think we will also learn about this. Basically, it's just the area of the force. Yes, this one, and we learn about the reaction since this is general mechanic, and equilibrium is one of the assumption that we usually use. Not all for all the cases, but this is mostly used. That means this ball, when it's attached to a rope to the ceiling, then this ball is going to stay there and not assuming this ball won't fall. Yeah, this ball has a weight. That means it has a gravity W, gravity force, and then that means the T that the rope need to withstand this weight, and the reaction is the T, and the T or the force by the rope, it depends on the weight and basically the gravity. Okay, that's the reaction, including anything that is standing on a floor. They need to withstand. All of them has a reaction. Like you sit down now on a chair, each of those part of the chair has the floor. I mean, has a reaction to the chair that is touching the floor with your weight. The unit, we learn about the unit as well, of the length, the speed, but force mainly Newton, and moment, I mean Newton meters. Okay, and learn about vector and the movement as a translation of fixed vector. I also show this. Yeah, could be different. Yeah, and the left and right is different of F, because the line of the force is different. So it's not the same case for the box. While this one is the same, even though the position on the left is in A and the right is B, but it's still in the same line of action, so it's the same line of work. That is exactly the same thing. Okay, and then we have this principle of transmissibility principle that you can move from point A to point B, and it's still the same condition, same force applied to this object. Yeah, this is this concept is used quite a lot to move the force to the place that we can easily calculate. Okay, and then any question before I move on to the next slide, to the next PPT, I mean? Okay, now the second one is this one, yeah. So system of force, we learn about resultant, which we can solve both either graphically or analytically. And then the method also we learn, we could do, hang on, this is in Indonesia, is it? Yeah, this one, okay. Graphical method, yes, this is what we learned, that we don't need calculator, but we need a ruler and a keen eye to see what's the measurement of the length. Yeah, and either parallelogram like this, you have to find the arc between F1 and F2, or triangle method, yeah, either on the top or the bottom. But everything in here, you need a ruler to do it, and the scale of the ruler that you need to know. The resultant force, if it's separated, that means you just need to find the extended line, and then you move the P to that point A, the cross, the yeah, point A, which these two extended line meet, move this P force and Q force, so you can find the resultant with graphically. And this one is with parallelogram and polygon, yeah, which if you have several, then you need to several way, like parallel method. In here, each of F1 and F2, you find the R, become R, several R, which you will combine with the other R, while in the polygon, you just put all this F based on the direction of the F, the original F, but in different place. So F1, F2 is exactly the direction of the original force, but the starting point is different. The starting point is the end of the previous force until you reach F5, and then from B to F5 is the resultant. Similar to this, the resultant as well. Okay, all of this is by graphical. And then we learn a lot is the analytical method, which we use cosine rule, sine rule. Yes, we will not have an open book test, I think, for the midterm. So you need to remember this formula. Sine rule, if we have this triangle, what's the R if we have F1, F2, or several angle, this will be gonna help you quite a lot. This rule, cosine rule and sine rule, to find out if we have this triangle. And then we have also discussed about this example. What's the reaction is both the roll out on the top and the bottom, right? And then the point A as well. So we learned that using the triangle, cosine rule, sine rule, it's very helping us to find out. So what's the distance? What's the angle? Yeah, and yes, like this. So this we have discussed this um, in that class, and about the angle. If you don't forget, not just to put what's the the degree of the angle, but also the expansion. So this one is, if in English is, so the direction is 3.6 degree from the horizontal axis counterclockwise. Yeah, this is what we also need. Don't just put 3.6 and that's it. Gamma is 3.6. What is gamma? That's just an angle. What we need to find to know is the direction. Yeah, you don't forget to put this on the test, on the answer test. Okay, and we learn about this resulting force on the roller, and I think you did also the class, yeah, for the bottom roller. This is the top roller, I think, and the bottom roller we have another one. Okay, for this example, do you have any question? Yes, before I move on. Was it all clear, or there is still something that you don't quite get it at the time? To now? Okay, looks like,
All good, Pak.
yeah,
All good, maybe.
sorry?
It's all good.
It's all good, okay. All right, didn't hear you clearly. Okay, so if it's all good, then I'm just gonna need to move about this component force that we learned that we can decompose, yeah, to make one P into P accent and P double accent and an X and an Y axis, the component of the force P. This is we learned, and this is very helping us to do the analytical calculation in the two-dimensional space. And like this P from point A, we can decompose into Px and Py, and we use this quite a lot. Okay, so we erase the P, and we'll have only Px and Py. The thing is that we need to calculate Px and Py based on this. Okay, Px is P cos theta if the theta is here, and Py is P sin theta if the theta is here in my mouse. Yeah. And tan also, if you need it, tan theta is Px divided Py divided by Px if you need it. Also, P, the magnitude of P or the length P is Px squared plus Py squared. Then the square root of those addition. And then we also discussed about this example, I believe, for the force. And then with the using symbol, basically we move from here, this point, to this worker, potential worker. Okay, we need to find out F1, and then we need to find out what's the worker need to hold, need to push. So when I would find out what is F1, this one also is not that easy, I think, for the one who's just start to learn. But this is using triangle basically and trigonometry, yeah, to find out what is F1 until we move it to this point that has the worker, which we have FP, and the FP is the final question. But how much as the worker need to push? And the answer is 27.994 kilonewton. Okay, is also one example of a sample question in the exam. Yeah, and this part is I think it's the most challenging part for those who are not used to exercise, and you're gonna have usually a bit difficult time to find out. So what is F1 from here? Since this is not 90 degree. Yeah. This one, let me know, yeah. Just interrupt me when you think that you were not that, you didn't get it much when, yeah. Which one? Which example? This one or uh this one? Oh, the exam is not using calculator? Usually you can use calculator usually, yeah, because it's just to find the sign of 50, or plus of, if it's very basic, sometimes it's okay with a calculator, but if it's like sine 35, you don't really remember those. Yeah, you could try to find out, but it's going to take time. If I think if the exam is not letting you use calculator, that means all those angle usually are very standard angle. If you remember the standard angle, the one that was given to you probably in high school as well, or in the previous semester, the what tan 45 or sine 60, cos 60, sine 30, cos 30, those very basic answer that you can just remember uh, what's all of those angle. If you cannot use calculator, that means the problem is going to be very simplified. If you can use the calculator, then yes, you might have some angle that you need calculator to find out. That's maybe the case. Yeah. Yeah. Okay. All right. Any other question? All right. I think we don't know yet, right? The announcement about what's the permission to use calculator, using calculator or not. But let's see. Okay. But I hope you can just check again. I sometimes we forgot. I even sometimes forgot like what's the basic sine or cosine or kind of very common angle, 30, 60, 90, 45, those four type of angle, and that you might want to memorize if it's not, you know, not allowed to use calculator. Yeah. And this kind of thing, the angle is not going to be 50 or 40 there, because then you need calculator to do this. Yeah. Okay. We also have this exercise, which is the cross section inside here. Sometimes we ask this because we want to know the strength of the this rod. Yeah, we want to know the strength. So we want to know what's inside the cross section and in certain angle. And this is what's one example of basically why we study this, because we want to know how strong it is, that the product that we make is going to withstand the force, the weight of the condition when the customer using it, right? So you want to know which part is that usually the most critical part that can, if that product or our product is going to fail, it's going to start in a certain point. Yeah, the weakest point, like it started to crack, you know, the shape is going to be different. So that space that where the critical point is, and that's where usually want to calculate using this engineering mechanic, like how much the force is actually need to withstand, apply to that point. Okay. And that force could be this in several directions. So using this analytical lineage, we can decompose all into x and y axis. And if you don't have the axis, just draw the axis. Yeah, draw yourself. Where do you want to be the x? Where is the x? Where is the y? As long as you know uh, the angle between P2 and the y-axis, for example, P3 with the x-axis, then you're good. If you don't know the angle, yet you need to measure the angle. Yeah. Don't forget the sign. If it's in the x positive is positive, x negative is negative. The sign of the direction, not the magnitude, because force is never negative. It's only positive, the magnitude. But the direction could be negative based on which direction, in which axis that is working. Okay. Here we have tangent also. There's another formula to help you find the resultant, the angle. Learn about these two probably similar concept that we need to decompose. Yeah, the force into x and y direction, x-axis, x and y-axis, and then if it's in equilibrium, that means the resultant of the force is zero. If it's not in equilibrium, then there is a resultant. Yeah, here. Like this also, we learn about this, how to decompose into x and y axis and just add everything and find out what's the r. The r could be not zero if it is not in equilibrium. That means using this, if we have like this, we have r which is 130.6 Newton in this direction, I think. Yes, what is it? This alpha 33.8 from the x negative counterclockwise. Then that means this condition, this point is actually moving toward that direction. Yeah. So that's the first step. If it's moving, that means if we want to put this point as a not moving, we need to put a reaction force equal to that resultant and the angle. That means we need to put a structure that can make this point of a certain object not moving. And that structure need to withstand this R in this direction. Okay. So that we learn about this. And I can try to, this is in Indonesia, but I think I better explain it in English. Yeah. Um, this one you might want to review again and see how it is being calculated, analyzed. And then we have, see, we talk about the resultant force, which we learn more detail of the free body diagram. Yeah, which the structure that is previously complex will become less complex and just include whatever it is that is crucial or important. That means we need to find out which part of the system that we want to put in the free body diagram. Like for example, this one, what our concern is point A, not point B, not point C, for example. But if you want to question point B and C, then means you need to draw the free body diagram of point A, B, and C. So if we concern about the people of here, yeah, how much these people need to pull, yeah, pull the rope. The thing is, when we have this roll mechanism, the TAB is if you find how much is TAB, that's also the same thing as what's how much the people need to pull the force. And TAC, since this is a roll mechanism, is it will be exactly the same as this guy, these people on the right, how much he needs to pull. Yeah, how much force. Since this is a roll. Okay. But this is the this is a PG, everybody there. Everybody, yes. Okay. Um, for this one also, so if you've shown something that, oh, like the real world diagram or picture, then you need to find out how to simplify it into this free body diagram. And might be much, much simpler than this. Okay. As long as you understand which point that you want that is crucial and point of analysis. Okay, this is an example point A, not C and not B, but A, which connect B and C. Yeah. Equilibrium force, as I mentioned before, it's the total force is zero in any direction because it's in the opposite direction of this force applied in one point. This one's also, if it's in equilibrium, that means it's going to be coming back to the beginning. F1, F2, F3, F4, F5, and F5 is going to finish in the starting point of F1. So it's an equilibrium, which means the total is going to be 0, and all the force will just if you add, it's not gonna have a resultant. The resultant is 0. That's equilibrium. Okay, we learn about this, equilibrium condition, and then the angle. Also another example that we learn. And then we need to make a free body diagram of this condition. So you need to find out where point that you want to put, like this one. And into this, you move into this. It's up to you, but you don't have to. Okay, the polygon depend on what analysis you want to use. Okay, and we learn about moment as well, which is basically the force multiplied with the distance to a point that receive a rotation effect of this force. Even though way it might not rotate, but because there is a structure that hold together, so this object is not moving, not rotating. But if there is no such structure, then this object will rotate based on the A point. In this case, is clockwise. Yeah, like this. So this moment, and if we have transmissibility principle, we can move F from here to here. Okay, and also here we can move the F from here and find out what's the distance. The distance from F to D, it has to be perpendicular. So this is not the distance. The height of the rod of the not the the head of the structure is not the distance, but you need to find out this D, small d. Yeah. Need to find out because this need to be perpendicular. The distance from the point has to be perpendicular with the line of force. So that's usually the tricky part that you need to find out the line of force to find the M, the moment. Or with the variant theory, we can just decompose the force so we can calculate. We have new two forces that we can now calculate the moment of these two forces and add it together, join together. Yeah. Again, if you need, don't forget to put the sign of this moment. Is it going to be plus for counterclockwise or plus for clockwise? So you know that, okay, if it is minus, that means it's in another direction. For this example, from point O, Fx is going to have a clockwise effect, the rotation of clockwise, while the Fy is going to have counterclockwise effect, rotation effect. In this case, you can see that this is F1 multiplied with X. That means it's plus for counterclockwise and negative for clockwise. You see it? Yeah. Yeah, this is one example that is not put in. Okay. I think I skipped this proof. But it's up to you if you want to learn, but the most important thing is this will not be asked in an exam, I think. But here, an example, different method than before. We just decompose this force and find out the M. For Fy is going from the D, the point that we want to look. That means it has no distance. That means the moment is 0. Yeah. F moment My is 0 because there is no D, while the Fx Mx has a D or distance, 2 meters. Okay, and we also learn about this. Whatever the shape is, this is the shape. Is just to help you calculate the distance. Okay, and this one also, I think we discussed this on the board the other time. Okay, and we also learn about couple, which is two forces that is going in the opposite direction with a distance like this. Yeah, learn about this couple, which is the moment couple, and the replacement couple, For this, if we want to distribute the P into different direction, then we'll have this couple, which is the same as this condition. Yeah, this one couple, and then we have resultant of single couple, which we can move all those forces. Also this one into this one, I mean, okay. Our transfer force and couple moment need to change. This is what you usually use quite a lot, is to transfer this F1. The first force is this F in point A, and the other is this F in point B. We just basically move the F in point A to point B to move from the top to the bottom. But since we pick this out, well, this one has a rotation effect of force in point B. That means we need to add this moment. So we will delete the rotation effect. Okay. This one is this is the one that we use even in second section. Yeah. This one is this just even if you want to combine everything, and then it still has a rotation effect M. So you need to put M based on the result. And if you have M in the resultant, that means the actual place of the resultant is not in point A, but somewhere that make this point A rotate it like an M. So this is what we need to find. It just actually, the R location is in S distance from point A in this direction. Because of this, then point A will need to withstand the rotation effect of R in the clockwise direction, just like this M. Yeah, and see in my mouse. So this is when we transfer a moment. Okay, this is another example that we learn about moving everything, all the force into point B and see the moment that we need to put based on the rotation effect of those forces, like this, until we found out O resultant and the direction. That means if like this, we find the resultant of all those forces, then the moment, that means usually the question will be, where is the actual line of force of this R resultant, which is in here, in with S distance from point B. So it will have an effect of rotation effect or moment effect like this in point B. Okay, this is what we learned from the resultant force. Any question up to this point? Okay, there's no question, then this is the example here that we did. Okay, this as well. Okay, for this condition, I have another example that maybe I can share with you. Sample answer. I think it is in here. You can check it again, and like this. This is it, but it's in Indonesian. Yeah. This one is similar but different, and this is the sample answer to find out what's the question is. The moment in C, or in here similar, the moment in this point, and this is the sample answer. Yeah, I think I can share this with you. I hope you don't mind. This is in Indonesian, but using from the formula, I think it's pretty easy to understand. Yeah, for the piston mechanism. It's inside the engine of your car or motorcycle. There. And this one that we learn about structural support, internal force and structural support. We have this roll support. Basically, we want to know what's the reaction force of this. Only one reaction, and it's perpendicular to the line of contact of this roll. while hinge support has two reaction R1 and R2 in X and Y direction. And the last one is clamp support, which has two force R1 and R2 with additional M to withstand the rotation effect, the force. Okay. You learn about this. This is also very important, and you're gonna use this quite a lot in session 2 to find out what's the reaction before calculating anything else. This is like the first step before you calculate other question in session 2. Okay. Like this, you need to find out what's the reaction force of A and B. Since this is hinge, so we have two reaction, which is this is roll. We have one reaction, and then with this we decompose this F into X and Y. So now we can calculate the sigma F, sigma Fx, sigma Fy, and in some point sigma moment A or B. Yeah, depend on what you need to answer. And we learned also distributed force with the line, just simply multiply the force with the length of the line. But if it's cross section, that we need to calculate the area, yeah, of this shape, like this. What's the area of this rod? Then it's just PR square, yeah. And if it's volume, then it's density, rho. But we don't really use this in engineering mechanics for the volume. Okay. Example of this, you just need to calculate the G with this 30 Newton per meter, and you just need to multiply with 10 meters, become 300 in one place in here, in a Q as a 300 Newton. So all of this just change into one force, and then you can calculate the distance of this and with the other thing, with the reaction. Okay, we found out what the mirror distance question is, reaction or something. Okay, and here we also learn in here. Yeah, if it's here, we need to calculate the total of this distributed force as a Q in here, and this is the reaction of this clamp. Yeah, condition. This is a clamp point. We have RAX, RAY, and MA. Okay, and then I think after that we just discussed about exercise. Yeah, I think it in Zoom as well. Yeah, about the exercise. Any question now about this part of the class? Is all of these examples you understand, or you some of these that are still a bit difficult? You can tell us now better than you get stuck on the exam. We don't know which one it's that come out, but this is some example that it might easily come out this type of question. This is maybe one of the easiest one if we have like this. Yeah, probably won't come out because it's almost all the lecture will think that this is too easy, too basic. But this type, for example, okay, it looks decent. This one, okay, it looks decent plus a bit of challenging because you need to find out where's the line of the coordinate. And this one as well, probably it's different, but it's interesting. Still using the same engineering mechanic principle. We have this, yeah, or this. I think we didn't get the chance to discuss this, but this is basically similar. And this is the solution explanation answer. All good up to this point. Okay. For me, actually, I will be well. So if I don't have a preference, but probably if you want to use all the same, then maybe plus for a clockwise is good. I mean, our watch is clockwise, everything is clockwise. So if it's plus, then maybe it makes sense. But you don't have to. If you want the clockwise to be minus, it's fine as well. As long as you put the sign, yeah, you put the plus and which direction. But if you make this whole plus, hmm? Yeah, as long as you uh um consistent. But if it's positive for clockwise, it's fine. Yeah, it's whatever it is, as long as you put in the front of the sigma MA, for example. This example does not have that sign, but if you, for me, I prefer that you put what is this plus? Is it clockwise or counterclockwise? So I know which one that you do correctly or you do incorrectly putting the sign. Yeah. For me, I don't have a specific preference since most of the example in the book or the internet, it could be anything. Could be clockwise or counterclockwise for a positive sign. Okay. If you want to have a positive for a clockwise, is good, but not for the other way is also fine. Okay. Any question? Any other question? So then I want to show maybe this just a concept that this concept that I don't know if it might be asked, but it's just very basic about what is a coplanar forces and what is non-coplanar forces. Um, it's more like conceptual. Might be asked, might be not asked in the exam, but basically what we learn here is mostly it's coplanar. So forces that act in the same plane is coplanar, while non-coplanar is forces that act in different plane. For a coplanar effect on the object can cause linear or rotational motion with the plane, within the plane. Yeah. While the non-coplanar can cause motion in multiple directions and more complex because using the coordinate for the coplanar forces, we only use sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. So this is most of what we use to coplanar force. While the non-coplanar source is not just fx, but we also fz. So we have a z direction in more a three-dimensional direction. The m also, not just mx and not just m, but we have m in x axis, m in y, and m in z. So it's more complex. Yeah. For this engineering mechanic, we use mostly on coplanar solid, but you know that in reality, you're gonna need to use non-coplanar force. So if you later on in the future will discuss about this due to force acting on your product, for example, and you want to discuss this with the mechanical engineering or civil engineering, then they will use the non-coplanar force because it's more toward reality. And you know, based on this coplanar, what's the difference? It's just you adding additional uh, axis, X, Y, and now we have Z. Yeah. Example of this, as we all have it or discussed, is coplanar. For example, another example is a book resting on a table with friction and normal reaction acting on it. So, like, we haven't learned about friction in the session 2, but we have a book that resting on a table. That means we have a normal reaction. Normal reaction is a reaction from the table to that book. So that book will gonna stay in the table and not fall or move, which is perpendicular of the contact point of that book. Normal reaction, we call it. Yeah. One example of the non-coplanar force are a tripod holding camera. Yeah, the tripod, you hold the camera, it's different direction. It's also tilted a bit differently, not evenly could be. So that's an example. Another example over this, you can see a coplanar like a ladder leaning against the wall with gravity. We have a reaction force with friction as well, so that ladder is not going to move and it can safely used by the people who want to use the ladder to repair something. Or another example, a bridge experiencing force due to vehicle and support, and with this all acting in a horizontal plane, and there is no vertical, all acting on, I mean, on the plane that has all the forces and the reaction is horizontal. The force could be vertical or tilted, but the plane that you use is only horizontal. While the coplanar, it's more like complex like drone. So you need to mm, know the lifting, the gravity, the thrust, the air resistance, the wind. That's more complex, yeah. But this basically just add more axis from X and Y into X, Y, and Z. A crane lifting a load, while the force it's has a vertical and horizontal plane, not just one plane, but vertical and horizontal is also an example of a non-coplanar force. Yeah, this is if it's being asked, since most of what we learn is the coplanar, but you may be asked, what is a non-coplanar? Yeah, okay. Any question on this additional concept? You think it's probably going to be too complex if you are asked this in an exam. Yeah, you've been, and I don't think you have enough time. But when reading this concept, you understand that okay, usually it's just fx, fy, and one m like this, and now we're just adding fx and y to fz now and some other moment. So still is almost exactly the same concept, just adding new axis. Yeah. So even if it's being asked, I don't think the being asked this it's going to be a bit too complex. But if you're being asked, then this is what you need to. The principle so is this, and if it's in equilibrium, if it's not in equilibrium, that means sigma fx is not zero, sigma fz is not zero. You have a resultant. Okay, here. All right. Any question? Any other question? Okay, I'm gonna share this here. I haven't saved this. Okay, I will stop sharing first. And while we're here, let me save this so I can share with you in this Zoom. Okay. Let me find thing that I want to share with you. Mm, Here, one of the file. And then, do you have all the PPT that I previously shared with you? All the one that I showed to you here. Do you have it all?
Uh, which one?
I mean, all the one that I show you in here. Do you have it all? I mean, have I shared you?
Oh yeah, already sent from the WhatsApp.
Okay. Just adding one example. I know it's Indonesian, but I think it's going to help you. One example solution of that piston mechanism. Okay, let me set it up first. It's yeah, paste an example. An Indonesian, but I think it's okay. I hope it's okay for you to understand. This is the good thing about math, yeah. Even though if you different language, but the actual language is still the same. It's the mathematical language, yeah. Sigma fx equal to 0 or something, a moment or the free body diagram. That's the actual language of engineering mechanic. Either English or Indonesia is still the same. Yeah, it's still the same free body diagram, still the same fx, fy, and so on. Do you get it? The chat, the piston example, and a Word file, Kupana versus none. Okay. Okay, so that's the additional one that I just need to add to you. And this is wrapping up what we have for this session 1. I'm gonna session 2 is gonna be based on the session 1. Then you're gonna use what you know about session 1 in a structure. So it's gonna be more, can I say, more complex. Yeah. So try to use this time to really understand not just the midterm, but for the session 2. If you're having hard time understanding in the session 1, then you're also gonna have a hard time session 2 even more, because they're gonna assume that you already know the reaction. To find the reaction, for example, you already know to find the supporting point, resultant force, moment, definitely, couple. They're gonna assume you already know that to calculate something else based on that. Yeah, to calculate construction of a car, of a building, and now we have movement. That means we have a friction now that we need to calculate. You also will calculate about gravitational, not the gravitational, centroid. Yeah, but centroid. How to find the middle. We did learn a bit about finding what's the middle of the distributed force, but later you will learn in session 2 about the more complex shape of the force, and you need to find what the centroid or the focus of the distributed force. Yeah, but that's for session 2. So now you enjoy this session 1. I'll try to learn, understand more, and hope you have a good exam. Yeah, good result in the exam. Okay. All right, guys. Yeah. All right. So thank you for joining me in the Zoom for this session 1, and for all the good and the bad thing that I tried to explain to you. If you don't get much, and just say I'm sorry, but I hope that you get what we want you to understand. Yeah. And if you still have Fadel as a class or the head of the class, you can still contact me in WhatsApp. If you have question, you don't understand something, you can contact me or email me, because I know that we won't meet again until the exam, right? Now it's holiday. We also have a good holiday for Idul Fitri. If you want to join with your family, if you can, or with friends, yeah. And yes, I hope you have a good holiday. Don't forget to study as well. Find a time to study, because after holiday you just have the midterm, straightforward midterm. Okay. All right, then that's thank you again, and I will leave you from here. Right. Bye bye.
Thank you, Pak.
Thank you, Pak.
Right.
Thank you, Pak.